Okay. Welcome, everybody. Thank you all for coming tonight and joining my presentation. We're going to be talking about start building, unleashing your project with AWS. To get started, who am I? My name is Stefan Tobler. I'm a principal cybersecurity engineer at Capital One. I really like computers. I've been playing around with computers pretty much my whole life. When I was 14 years old, I started to build my own PCs, and I was making Minecraft servers for my friends. Went and got my undergrad in CS, and I've been working in the computer industry ever since. Other than that, I'm really into wind sports. So if you want to talk about sailing or kiteboarding, I will talk to you about it for hours. So be careful if you're getting into that with me. And lastly, I'm pretty new to Charleston. I just moved here in August of 2023. I'm from South Georgia originally, so it's nice to be back in the South. I was up in Northern Virginia before that. So what are my objectives for this presentation? Ultimately, I want to inspire you all to ideate, build, and deploy applications on AWS. I want to demonstrate how we can use AWS to take our ideas from paper to reality, and then I kind of just want to show off what I've been working on over the past few weeks or so. Who here has ever had an idea that they want to build into an app? Most of us, I would imagine. And who here has started an idea and then not finished it? Yeah, also all of us. So it's awesome to see everybody raise their hands, because I think it's really important to show that we're all on the same page. We all have great ideas. We all work in technology and software, but sometimes actually fulfilling them is tough. So hopefully you can take away something from this presentation on how to use the AWS toolbox to kind of build your ideas and make them a reality. First off, I kind of want to talk about what I'm trying to solve in my problem statement. I like to subscribe to newsletters. I always end up giving people my email just so I can get more spam from somebody else. But there are so many smart people out there who all have their own newsletters on their own websites. And it can be a challenge to follow them all. There's great platforms out there like Medium where people can post and cross-post their own articles, but ultimately some of the greatest content I found is still on people's websites alone. And then newsletters can be verbose. Sometimes I'm just looking for a TLDR. I don't want the whole 5,000 word summary of what this guy's got to talk about, how to go from a junior dev to a principal lead at some big FANG company. Sometimes I just want the short, brief bullet points. Do I need to talk more in meetings? Do I need to talk less in meetings? How does that work? And then finally, with all the LLM craze and AI craze, I really wanted to see where I could apply a large language model to my problem. So my solution was to try to build a platform that'll summarize and allow listed newsletters using the Claude 3 LLM, tag those articles, and archive them for discovery. The solution also needs to be cheap because I don't have a bankroll like I do at work, so it's a little bit different when money's coming out of my own pocket. So the original idea came to me maybe in the early January, and I kind of just sketched out something on paper. I really wanted to kind of put this in here to show you that you don't need to have really hard and solid ideas and solutions. You can start from scratch, and then to move forward and not let you look at my horrible handwriting for too long. Here's the idea. Here's the original design kind of put into a diagram. So what I wanted to do was use a Lambda function to call the Google API or the Gmail API, grab the newsletters I'm interested in, and then put them in SQS queue that then spun up a SageMaker EC2 instance and blah, 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 blah. It was really complicated. And honestly, it was going to be really expensive because SageMaker EC2 instances have to run on instances with graphics cards, and then you get into the dollars per hour range, which can quickly add up if you are talking about a daily timer or just the amount of time it takes to provision one of these EC2 instances. So my first big hurdle was kind of deciding on a mail service. I needed somewhere that was kind of isolated, an inbox that didn't have all the noise of my usual inbox to sign up to these newsletters. So originally I was going to go with Gmail. That's $6 a month. Then I was like, if I'm going to be paying, I might as well try to learn something. So I moved on to Mail in a Box. Mail in a Box is kind of like an all-in-one mail server you can host on EC2s or any sort of elastic compute instance. And then my friend was like, no, you should go to Zoho. Zoho has a free email domain if you just have one, you own a domain name. And I own stephantobler.com, and I own a few others as well. And then finally I looked into Amazon SES. Ultimately, I ended up picking a combination of Zoho and Amazon SES. Zoho gives me control of the inbox. I can pick who I'm subscribing to. I can actually go into a UI and say, hey, I want to unsubscribe. Hey, I want to delete this email. So it gives me a lot of flexibility to see what's going on. And then Amazon SES allows me to interface with AWS components easily without having to worry about a Zoho API, migrating my API keys, and doing secret management and all that stuff. So that's where I decided to move forward from. Going into the cloud, I decided to go with Pulumi as my infrastructure as code. I know that some folks here had mentioned it and some folks here had advocated for it, so I decided to go for it. I previously worked with Terraform and some CloudFormation templates, but I really didn't want to be just writing YAML and stuff I didn't completely understand. I really wanted to be writing in the programming language that I was already going to be building my application in. And then for those of you that don't know, infrastructure as code is super important in making our deployments repeatable and precise. Throughout this process, I built my AWS Lambdas hundreds of times, probably more than that. And having to do that through the UI and through the console would have been extremely time consuming. Being able to just hit the up arrow and do a Pulumi up saved me countless times. And also, IaC is precise. It deploys exactly what I write into the code, and I don't have to worry about misclicking in the UI or after a tired night of programming. And this ended up being really valuable. Over the course of this project, I ended up accumulating about 240 different resources in AWS. I will say a lot of this is due to a static front end I deployed. So there's like 60 files that make my front end work using all the React components. But there's just so much more than your Lambda. There's also your IAM roles and your policies that make managing this stuff really, really easy. Going into programming the real solution, I redesigned the intake. I realized that SageMaker wasn't going to be the right solution. SageMaker was super expensive, and I think at reInvent this year, AWS announced Bedrock, which is where we can interface directly with these LLMs and directly with these AI models through simple AWS API calls. So I can prompt the Claude model, I can prompt the Llama model, whatever model I choose, and there's 15 or 20 on there that are free to sign up for, but it does cost when you send tokens to them or send input to them. So just a quick walkthrough of this architecture. I am a big architecture nerd. I really like drawing out what I'm doing and putting it on paper. So bear with me. And if you have any questions through this process about what any of these services are, feel free to raise your hand and ask. This isn't strictly a presentation. It's also a discussion. And I'm happy to clarify any architecture decisions I made or about any services. So over here, I'm missing Zoho, but ultimately, Zoho will forward emails to SES. There's a filter that says, hey, for any email inbound to tech letter intake, I want to send SNS notification, and I want to store that email object in my bucket. From there, the SNS message fans out to any number of SQS queues that are listening to it or any other listeners. The reason I like to put SNS topics in front of SQS queues is because it gives me a lot of flexibility in the future. If I want to expand consuming these SNS notifications or these email notifications to do, anything else, process that email on a separate service. Maybe I want to do a comparison where I'm using the Claude model and then I'm also using the Llama 2 model or some other Anthropic model. I can do that. And then from there, an intake Lambda takes it, sends it to Claude, says, hey, here's what I kind of want you to do with it. Give me some JSON output. And then it'll store the summary and the tags that the Claude model generated into my database.
What was the software you used for repeated icon?
One more time?
What was the software you used for making this?
Yes, I use draw.io, and it integrates really easily into your Google workspaces, like into your Gmail and Drive. And then also, like, if you use Jira, there's like Jira plugins for it. So that's kind of why I got started, because, not Jira, excuse me, Confluence. But yeah.
It's free.
And it's free, which is big. Go ahead.
Why do you have the SNS and SQS stacked, like, right next to each other like that?
So SNS is fanning out, like you're talking about these two right here, because SNS sends out SNS is a pub sub kind of system. So what I can do is I can publish a message to SNS, and then everybody subscribe to the SNS topic, it'll broadcast it too. So the SQS topic here, the intake SQS is subscribed to the SNS topic. So for any SNS message that gets broadcast, this SQS queue will then grab it. And then SNS is really powerful too, because you can filter on all sorts of things. So you can add custom attributes. So maybe I have some sort of extraction data pipeline. If I want, I could say, hey, for data in this data set, I only want my SQS queue to subscribe when the attribute is dataset X or dataset Y. So then all of these SQS or SQSs could receive different messages from the SNS, and I just have a generic topic that I can publish to. And then SNS is also really powerful. You can subscribe emails to it, you can subscribe phone numbers to it, and there's a lot of other AWS services that can hook into it. But good question. So moving forward to that, this is when I kind of ran into my first big issue, my first roadblock. All of a sudden, my girlfriend and I, we were driving back home from St. Simon's over the weekend, and I had been working on it earlier in that day, and I get home and I open up my email and all my budget alarms go off. Literally, I can't even respond to them before they go off. Like, it's just all at once. And I go look at my Lambda invocations, and I've kind of had a little bit of a Lambda runoff. You can see that for about 7 hours, I was invoking, I don't know, I think it ended up being like 35,000 invocations, something crazy. But fortunately, it wasn't super expensive. It ended up costing me about $65. Then after some further development, it was $75. What ended up happening is I did not have this DLQ in the first place. So when I was writing bad code for my intake Lambda and it was throwing errors, it was just going right back into the queue and then right back into the Lambda and over and over and over again. And Claude is not the cheapest model to be running on. And I was also sending like the full email body with like the base 64 encoding and everything. So one email was like, one email is not expensive, but 35,000 of them started to add up. So this is a good learning opportunity. I know that like, it's easy to say, hey, make sure your bad input doesn't make it back into your function. But this is kind of a good sting, put some fire under me to actually remember that. So always set up a DLQ if you're having a queue-based Lambda, or somehow kill your messages. Yeah.
SQS also has a retention time, so when you're playing with it, it's good to set it nice and low, so you know it only gets a couple cycles before it drops off.
Yeah, for sure. Yeah, that's also a good call out. There's a lot of SQS stuff that you can do to manage, the input risk there. Because some messages you may want to retry, so you can set a specific number of retries on those messages. Say, hey, I want to retry a message 5 times before it goes to a DLQ, and all this stuff. But yeah.
So how did the DLQ fix that?
So the DLQ, what that does is the DLQ is a configuration you can put it on the Lambda and the SQS topic. And what'll happen is if your Lambda exits with an error after a set number of retries, then the message will end up in the DLQ, and it will just exist there until it's either triaged by a person or you have another system that's alerting on the DLQ. Where this can be really helpful is maybe there's a code error and maybe it's not an input error. What you can do is you can fix your code, and then your DLQ exists as a DLQ. It's a special type of SQS or a queue. And then you can just hit one button and redrive all those messages to go right back into your intake Lambda. So that's why kind of right here I said, unless it's driven back by a human, because a lot of the time you may be running an application where all the input is important, but bugs happen, and sometimes things are different, and we need to just go back, fix that, and then redrive those messages. So if we go all the way back to the original design, we have an API down here to interface with the data that we put into our DynamoDB. So that's the summarization, the original newsletter, and all that stuff. And this also needed a slight redesign. It's pretty similar to the original design, but actually it's almost exactly the same as the original design, except for the fact that there's a little certificate here. So all of the endpoints are signed, and you are getting secure HTTPS over the web. But yeah, so for our API design, we just have an API gateway that uses Lambdas as integrations. Each of these integrations owns a specific service. So if I decided that I wanted to summarize or do news articles, maybe instead of newsletters, I could have a /news endpoint, and maybe there's different details or different attributes that I want on those models, and the future services can easily plug into there. And this is like really one of the great things about AWS, and one of the cool things about designing applications in AWS is that if you design your applications very consciously, you can design them to be very expandable. I don't have to rewrite any code to add a Lambda function. All I have to do is add an integration to my API gateway, and then boom, I have a new endpoint on my API domain. So that kind of stuff is really important. And then here's an example of it actually getting to work. So the Lambda calls back to our database, and it has read-only permissions set by our AWS policy. So its execution role only has read-only policies on it. So that prevents us from potentially writing back to the database if we don't want to. And then redesigning the front end. Originally, once I kind of went down the API gateway route, I was thinking, hey, I'm just going to put my static front end behind the gateway as well. Read up on that a little bit on the internet, said you can do it, but it's not necessarily the best practice. So I decided to go with a CloudFront CDN, content delivery network. What that does, as opposed to using just a regular S3 bucket for your static front end, is the CDN will cache responses. So rather than having the files sit in the S3 bucket in the US East region, CDN runs on the edge. So if you're in San Francisco and you query my front end, that static front end file will sit on a content delivery node in San Francisco, rather than having to call back to US East 1 every time. For an application of this size, it doesn't really matter. But when you get into like really latent sensitive applications, this can be a big speed up. And then again, this is signed with the AWS certificate that is mapped to my domain. And then hosting my first static content, that was pretty awesome. And then I just want to remind y'all, this is the original design, and this is it at the end. So users hit the public internet. My domain's at stefantobler.com. Any subdomain gets resolved on the Google DNS servers. And then I have two domains stood up on AWS, my API domain, and then also a static domain on CloudFront. And then this is kind of how all those services integrate together. And then this is where we're at now. And then we'll kind of do a quick demo of the service. And this, I don't think was supposed to be there. So I'm going to go ahead and just publish this blog post I made a very long time ago to my intake. And then we can see it be summarized and pop up on the website in real time. So for context, this is the website. If I refresh, this post is currently not there. We can see that we have a number of newsletters that are present. And then I'll just call this, I think this is called Begin Pen Testing. We'll go ahead and send that to my tech letter intake on my SES domain. And then in a few moments, we'll see it show up shortly. But so this is the application as it runs native to the web UI. We have all of our newsletters in descending order of date published. So the most recent newsletters will always show up at the top. We have our summary here and some tags that our LLM generates, and then also the author. If you go ahead and click on the newsletter, it'll actually be rendered in an iframe on the page. One of the potential issues later on is I think that I read an article about how to prevent like use of scripts in the iframe, but I think if you send like a malicious payload, it'll render it and hopefully the script won't execute. So I challenge any of you to try that. At the end of this, I'm gonna open up the allow list, I guess, for the remainder of the evening. So you guys can mess around as you please and see your content show up on here. Just please don't put anything profane or bad. But you can see the original content of all the newsletters within this iframe, as well as the summary that the LLM generated. And this works for most of them. You can see I forwarded them a lot to myself. And the prompt for the LLM needs a little bit of work. They pretty much all start with this newsletter discusses or this newsletter summarizes. So it's a little bit robotic, but that all just comes down to directory, and then I'm just going to run a Pulumi up on my dev stack, and then this will be deployed to AWS right now. So if you send an email before this finishes deploying, you will not see it. If you send an email after,
What's the email address?
you will see it. One more time.
What's the email address?
I'll put it back up once this finishes. So a Pulumi deploy is as easy as running Pulumi up. It tells you exactly what's changed here. So we see that there's a diff in our code on the tech letter intake. And then I just hit, I want to deploy that. And then this is the email address. But our Pulumi deploy is finished. It took 15 seconds, and now our latest code is in AWS without me ever having to interface with the console. And then we can refresh and see if anybody's stuff has made it here yet. As I pray that nothing is broken in my code that would prevent anybody's messages from not showing up.
What was the email address again?
Unless that code didn't upload properly. Nothing like a live demo that doesn't work, am I right?
Is your SES, is it allowing for unverified email addresses?
It should, because it's just that the email I have set up is I own the domain, so any emails that go to that domain should end up in SES.
Okay. I've noticed there's some weird restrictions in SES that
Yeah.
I'm on it, so.
It could be this just ran. And yeah, so it looks like there's an exception. So my code doesn't work as I would expect. But, okay. Gotcha, because I don't use the, okay. Oversight on my part. But I can fix that, and then if you guys are interested in playing around with it tonight, you can. But we'll jump back into the slide deck. So some potential issues with my solution are, like I had mentioned before, there's a security concern of some cross-site scripting. I followed a tutorial about using an iframe, like not allowing any scripts to run, only allowing content from certain origins to run, so it maybe is secure, but I am not the best web developer out there, so I would not trust the iframe that I wrote. Another potential issue is unsubscribing, since I am just publishing emails to the web that probably have some unique MailChimp token that will allow me to unsubscribe very easily. Other people could do that as well now that I publish them on the internet. So unsubbing from newsletters could be an issue. And then there's a lot of email encodings out there that I didn't test of all of them. So it is likely unable to parse some of those newsletters. And then finally, just one for symmetry, cold starting lambdas. Lambdas, if they are not being actively used, have what we call a cold start. So that means it takes, a few seconds is I think liberal, but no more than a few seconds to start back up. And if you hit the website for the first time after about 15 minutes, you'll notice that it definitely has some latency when loading the page contents in. But like I said, Lambda cold start is not the biggest issue. If you have users hitting it continuously, it's a great, it'll hold up. And also a great thing about Lambda is that it's like almost infinitely scalable, right? So if I start hitting, 100,000 requests per minute to this website, like my CDN for CloudFront should scale up, and then Lambdas will just start popping up out of nowhere and handling it concurrently, assuming that your Lambda is set up to execute concurrently within its reserved concurrency. Other than that, that's pretty much it. If you have any questions or have a project that you want to work on, I'm open to collaborating and offering the little bit of expertise I can. But you can find me on LinkedIn at Stefan Tobler. There's my email and my website. The website doesn't get kept up to date, so visit it as you may. But yeah, that's it.